reaction, volume of plug flow reactor is equal to mixed flow reactor. For all others, volume of mixed flow reactor is always more than the plug flow reactor volume.
Yes, sir.
Any other questions? You can see this plot again, the log plot. On the y-axis it is tau C naught raised to power of n minus 1 for mixed flow upon tau C naught raised to n minus 1 for plug flow. And you see that for all cases it is always more than 1. Even for 0.25 n equal to 0.25, order equal to 0.25, it is more than 1. Only for 0 order it is equal. Okay, so let's proceed from there. Next topic is, we have seen this also, PFRs in series and parallel. Now we'll see mixed flow reactors in series. Okay, so if we take a number of mixed flow reactors and put them in series, just like we did yesterday for a plug flow reactor, what happens in this case? And in this case, what you have taken is C naught is the initial concentration to the first CSTR or mixed flow reactor. Conversion is 0, F naught is the flow rate, and V is the volumetric flow rate. Then C1 is the concentration at the end of first reactor, X1 is the conversion. Similarly, C2 is the concentration at the end of second mixed flow reactor, and X2 is the conversion, like that. Okay. So let's consider first order reaction, and for liquid phase, so epsilon A is equal to 0. So we know that mixed flow performance equation given by equation 1, tau is equal to Ca naught V upon Fa naught is equal to capital V upon small v. That is equal to Ca naught Xa upon minus Ra, or you can write Ca naught minus Ca upon minus Ra. Okay, so if you do this, apply this for the first reactor, you get tau 1 is equal to C naught, which is in this case concentration, inlet concentration to reactor 1, into V1, volume of reactor 1, V1 upon F naught. F naught is molar flow rate, and that is equal to V capital V1 upon small v, and that is equal to C naught as the initial concentration into X1 minus X naught, which is nothing but yeah, instead of Ca naught Xa, we have put this one. X naught in this case is we are taken as 0, right? If it is 0, it will be like C naught X1. If there is some conversion before it enters the reactor, then that's why I taken X1 minus X naught. Okay, and divide by minus Ra for the reactor 1.
सर माइनस क्यों किया वहाँ पे?
See, this is actually कितना reaction हो रहा है, right? Ultimately, what is this? If you look at this one, what does C naught Xa mean? C naught Xa represents what?
कितना रिएक्ट हुआ है?
Right. So A reacted upon rate of reaction, right? A reacted is in moles per cubic meter or moles per liter, and rate of reaction is moles per liter per hour or per second or per minute. So then you get tau in minutes or seconds or hours, right? But if suppose instead of this X naught equal to 0 nahi raha, suppose this was not the case. Suppose X naught is not equal to 0. then you have to account for that, right? Initially कितना conversion हो चुका था और बाद में कितना हुआ reactor में. So because in this reactor conversion is x1 minus x0, net conversion. When x0 equal to 0, then it becomes c0 x1, which is like this one.
Yes, sir.
Okay. Any other questions? Okay, so you can write similarly for the ith reactor. Tau I is equal to C naught into, instead of 1 it will be I, Vi, capital Vi upon F naught is equal to capital Vi upon small v, and that is equal to C naught into, instead of 1 it will I xi minus 1, x0 gave away, divided by minus Ra for ith reactor. General equation लिखा हमने for any reactor now. Any questions on equation 3?
सर अगर हम सेकंड EMFR के लिए इक्वेशन लिख रहे हैं तो xi-1 का मतलब क्या होगा?
आप क्या बोल रहे हैं?
सर पर्टिकुलर सेकंड रिएक्टर जो है ना उसके लिए इक्वेशन कैसा आएगा?
It will be C naught x2 minus x1 divided by minus Ra for second reactor.
ओके सर.
Right? For second reactor.
सर C1 होगा ना?
नहीं, C1 नहीं होगा. जनरल इक्वेशन लिखा है हमने C naught. And that's why we are taking xi minus 1. ये पहले भी एक बार हमारा
सर
डिस्कशन.
अगर हम ओवरऑल कन्वर्जन देख रहे होगे तो x1 की जगह x0 आएगा क्या?
नहीं, for that particular reactor conversion is x2 minus x1. x2, if I take second reactor, x1 is inlet conversion, outlet is x2, and this conversion is always based on feed. Sorry. Conversion is always based on feed. It is not based on inlet concentration. ये पहले भी एक बार हम डिस्कस कर चुके थे, राइट? याद आ रहा दीक्षिता?
Yes, sir.
So it is conversion. When you talk about conversion, we are always talking about feed to the system. This is a system of n reactors, right? It's not separate. It just happens that one reactor is in series with second reactor. But overall feed जो है हमारा conversion यहाँ का निकालने का है कि यहाँ हमने feed जो दिया उसका total कितना conversion हुआ. So it is to be based on feed to the reactor system, not to individual reactor. And that is why it is x1 minus x0, x2 minus x1, xi minus xi minus 1, because that is what is accounting. जैसे अब ये देखा हमने, right? So if I take this C naught x2, what is C naught x2? C naught x2 is how much reactant has converted till the second reactor, right? Second reactor का आउटलेट जो फीड की बेसिस पर कितना कन्वर्जन हुआ और इनलेट में कितना हुआ. This is inlet to second reactor, right? C naught x1. This is outlet of first reactor. तो नेट कितना हुआ second reactor में? C naught x2 minus C naught x1. That is why it has to be C naught, C naught, not C naught and C1.
मतलब सर वो सिंगल रिएक्टर के लिए है क्या?
सिंगल रिएक्टर के लिए वी आर टॉकिंग अबाउट इन ith reactor. In any particular reactor, it can be first, second, third, fourth, fifth, nth reactor. But for one particular reactor, उस reactor में उस reactor का performance equation क्या है? Is that clear?
Yes, sir.
Yes, sir.
Chitra? ठीक है? And that's why we are taking C naught into x2 minus x1 or xi minus xi minus 1. And rate of reaction is for that particular reactor. उस reactor में क्या rate of reaction, because concentration every mixed reactor में different है. ठीक है? Okay, so Ca is equal to Ca naught 1 minus Xa. So C1 will be C naught 1 minus Xa और C naught minus C naught into Xa open किया तो. So x1 is nothing but C naught minus C1 upon C naught or 1 minus C1 upon C naught. So we can write xi similarly C naught minus Ci upon C naught or 1 minus Ci upon C naught. Or xi minus 1 will be 1 minus Ci minus 1 upon C naught. Writing that same equation, जो Ca equal to C naught 1 minus Xa in terms of I and I minus 1. ठीक है, equations 4 and 5. Okay, so then rate of reaction for the ith reactor is nothing but K into Ca because we are taking first order reaction. Now we substitute all these values 4, 5, 6 in equation 3. Equation 3 is this one. So xi निकाला, xi minus 1 निकाला, Ra1, Rai निकाला. We're going to substitute in this equation, and what we'll get is tau I is equal to C naught है यहाँ पर ब्रैकेट में xi minus 1. So xi का वैल्यू डाला 1 minus Ci upon C naught minus xi minus 1 is 1 minus Ci minus 1 upon C naught upon K into Ci, that is minus Rai. Right? So 1 1 कैंसिल हो जाएगा. ठीक है, ये C naught जो है C naught कैंसिल हो जाएगा. पहले 1 1 कैंसिल हो जाएगा. ओपन करके बताऊंगी आपको. और इज इट क्लियर? So C naught कैंसिल हो जाएगा. And what you get is tau I is equal to nothing but Ci minus 1 minus Ci upon K into Ci. ठीक है. Okay, so there is no questions. We can write K इधर लेके आया, K into tau I is equal to डिवाइड किया Ci से Ci minus 1 upon Ci minus 1. और you can write Ci minus 1 upon Ci is equal to 1 इधर लेके आया plus K tau I. इक्वेशन 8 में किसी कोई डाउट है, क्वेश्चन है? Okay, so now if you assume that they are all same size, right? The size is same. ऊपर ही बोला था हमने same size reactors. So if they are same size, then tau is same for all the reactors. That means tau 1 is equal to tau 2 equal to tau I, right? So now we can write, if you want to find out conversion for the nth reactor or concentration at the end reactor, we'll write C naught upon Cn nth reactor, and we can write this as C naught upon C1 into C1 upon C2, C2 upon C3 like that, series करके up to Cn minus 1 divided by Cn. Because now we have this thing, right? Like this is C1 upon C2. So we can substitute for C1 upon C2. C0 upon C1. We can substitute for C1 upon C0 upon C1. Like that we can substitute for each reactor or each of these terms. ठीक है? So then we substitute from all the terms, like C0 upon C1 लिया ऊपर में ये क्वेश्चन लिखा था. C0 upon C1 लिया तो it is 1 plus k tau 1, right? C1 upon C2 1 plus k tau 2, C2 upon C3 1 plus k tau 3, but we know that tau 1 is equal to tau 2 equal to tau 3. We can write tau I instead of that. It is common, equal for all, right? And Cn minus 1 upon Cn will be nothing but again 1 plus k tau I. Then we substitute all these values, C0 upon C1 versus etc. etc. And what we get is C0 upon Cn, because we are substituting here C0 upon C1. ये term हो गया, there will be n terms, right? So 1 plus k tau I raised to power of n हो जाएगा. Any questions on equation 11? Okay, if there are no questions, let's proceed. So we know that Ca equal to C0 1 minus Xa and Cn is equal to overall लिया तो C0 1 minus Xn. Where the base is C0, that's feed to the reactor, Xn is total conversion. So C0 upon Cn is equal to 1 upon 1 minus Xn. Right? So we can write this as C0 upon Cn is equal to 1 upon 1 minus Xn is equal to 1 plus k tau I raised to power of n. Or we can write as 1 plus k tau I is equal to C0 upon Cn raised to power 1 by n, because the power जो है we have taken 1 by n power, तो 1 plus k tau I हो जाएगा, यहाँ पर 1 power 1 by n हो जाएगा. And then we can write tau I is nothing but इसको इधर लेके आ गए हम, -1 हो जाएगा और ये 1 upon k हो जाएगा. 1 upon k C0 upon Cn raised to power 1 minus n minus 1. So if you know the initial concentration C0 and if you know the final concentration of nth reactor and we know number of reactors n, then you can find out what is the value of tau I for equal sized mixed flow reactors. Anybody has any questions? Devendra?
No, sir.
Okay. दीक्षिता समझ में आ रहा है?
Yes, sir.
So if there are no questions, let's proceed further. So यहाँ से जो लिया हमने उसका उल्टा किया हमने यहाँ पर Cn upon C0 is equal to 1 upon 1 plus k tau I raised to power of n. इसको भी अगेन 1 by n से पावर ले चेंज किया तो Cn upon C0 is 1 by n is equal to 1 upon 1 plus k tau I. Or you can write Cn, यहाँ से लिया ये. So there are different forms of equations. Cn is equal to C0 upon 1 plus k tau I raised to power of n. So different forms of the equation. Basic equation यही है जो ऊपर आया था, but we can write different equations for the different forms of the equation depending on what we want to calculate or what data is given. Any questions? No. Okay, so from 13 if you take equation 13 से, so tau for n of hours total लिया तो is nothing but अगर n reactors है, so it will be total tau will be tau I into n, because tau I is common equal residence time or space time for each reactor. तो total जो रहेगा for n reactors it will be n times tau I. So then we can write this as, instead of 1 by k, it is n by k हो जाएगा, c naught by cn raised to power 1 by n minus 1. कुछ नहीं, सेम फॉर्म है, but we are just multiplied by n, equation 13 को, because that is total space time for the n reactors. ठीक है, any questions on equation 17? Okay, so now what we'll do is we'll say if n tends to infinity, what does equation 17 give? So tau of for n FRs will give actually 1 by n, 1 by k ln c naught upon ca. Derivation मेरे को पता नहीं है, but that's what it is. I have not seen it, but assume this is given. So if I take infinite number of, infinite means basically large number of mixed flow reactors, I'll get 1 upon k ln c naught upon cn. That is total mixed flow reactor space time or residence time. Any questions on equation 18? Derivation I don't have it. मैं देखा but I could not find it. Just assume it is given. थोड़ा lengthy है, थोड़ा complex है. Okay. So then if we compare with PFR, first order reaction, हमने first order लिया था starting में, right? So we have equation for PFR is k tau is equal to 1 minus ln 1 minus xa, right? ये याद है आपको, right? For PFR first order reaction, k tau is equal to minus ln 1 minus xa, and 1 minus xa is nothing but cn upon c naught. Again, xa is xn, suppose you say 1 xn. तो माइनस ln cn upon c naught हो जाएगा और ln c naught upon cn हो जाएगा. So if you compare these two equations, do you see similarity? Is there any similarity?
सेम है सर.
Same, exactly same है, because this is nothing but tau. Right? ये k इधर का इधर आ गया, 1 upon k ln c naught upon cn. That means if I take a large number of mixed flow reactors in series, the system behaves like a large plug flow reactor. So if you compare 18 and 19, the volume required for a given conversion XA decreases to PFR volume as the number of reactors increases. The greatest change takes place with the addition of second MFR. Because एक reactor भी second reactor है, तो सबसे ज़्यादा change होता है volume में. Right? So ultimately what happens? Now, if I take 3 reactors, it is more closer to PFR. If I take 4, it is still closer to PFR. If I take 5, it's still closer to PFR. That means as I increase the number of MFRs in series, the behavior approaches the behavior of plug flow reactor closer and closer and closer. Any doubts, questions on this? Because this is an important concept, you should understand this.
सर सिर्फ फर्स्ट ऑर्डर के लिए ये है ना?
No, it will be for all the reactor, but see derivation becomes more and more complex as we increase the order of reaction. जैसे यहाँ पर हम देखा ये जो है going from equation 17 to 18 derivation, I am sure there is a complex derivation, I don't know, मुझे कोई मिला नहीं. So as I increase the order of reaction, again the equations become more complex. But doesn't matter what is the order of reaction, because first order is easier to handle. That's why it has been shown as an example of what kind of behavior mixed flow reactors in series will have compared to plug flow reactor. जैसे हम कभी भी करते हैं ना थर्मोकेमिकल, वी ऑलवेज स्टार्ट विद सिंपल केसेस एंड देन वी एक्सट्रापोलेट. तो ये सिंपल केसेस फर्स्ट ऑर्डर रिएक्शन, देन वी आर सेइंग कि ये ऐसा होता है तो सबके लिए होगा. इट्स ऑब्जर्व्ड. दिस इज जनरल ऑब्जर्वेशन. And there's a logical explanation. I'll give you that also. But mathematically, ये explanation है. That is, larger the number of MFRs in series, closer the behavior of the system is to PFR. Right? So in PFR, concentration of reactant decreases gradually through PFR. Right? याद है आपको? Slowly it increases from inlet to outlet. In MFR, concentration of reactant drops immediately to reactor exit concentration. ये भी देखा था हमने. Right? The MFR is more efficient than PFR is more efficient than MFR. ये हमने देखा था. Right? So logical explanation I can give you. मैंने बनाया नहीं है यहाँ पर, but I can draw it. If I draw concentration versus length of the reactor, right? This is say L, right? And this is your PFR. So inlet concentration is C naught, and say outlet concentration is CA. So the concentration profile is something like this. ठीक है, बराबर. ये हमने पहले बताया था आपको, याद आ रहा है? So it's not suddenly becoming like, if you take MFR, MFR का बिहेवियर कैसे रहता है, याद है किसी को? Correct. So suppose I say that this is PFR and this is MFR. And I'm putting five MFRs in series. ठीक है, तो क्या हो जाएगा MFR में? How is the concentration profile in MFR? याद है किसी को?
सर वो पहले ड्रॉप होगा और बाद में कांस्टेंट रहता है ना?
Right. Right. So in MFR, what happens? Suppose this is CA naught. Or maybe I should draw it here instead of that. Okay, suppose I take this, instead of doing it there, I'll draw it here. So if I take CA naught here, at the end of CA1, this side, CA1, no, not CA1 actually, CA1 will be somewhere क्या हुआ? Okay. So this is the first MFR. Okay. The second MFR में क्या हो जाएगा? Again, it will drop to some other level. Third MFR में again, it will drop to some other level. Right. So this is how it happens, right? MFR में ऐसा होता है कि suddenly यहाँ drop हो जाता है. It becomes CA1, CA2, CA3, CA4, and then CA, right? So this is CA1. Right? And it is CA. So that's what happens in CA, MFR. It gradually drops. पहले इसमें drop हो जाएगा, conversion कुछ आएगा. Suppose x1 is conversion, is x2, x3, x4, and xn. Right? So धीरे थोड़ा ड्रॉप होता है, फिर दूसरे में जाता है, जहाँ ड्रॉप होता है, फिर ड्रॉप होता है, till it reaches the final conversion or concentration. But MFR में क्या होता है, PFR में क्या होता है, gradually it reduces. So what is saying is, जैसे मैं number of reactors MFRs बढ़ाऊंगा, तो क्या हो जाएगा, ये एरिया और कम हो जाएगा, right? Instead of here, it will be maybe here. If I make it to increase infinite, so क्या हो जाएगा, ये एरिया जो हो जाएगा ये कम हो जाएगा. So essentially what it means, as I increase the number of reactors or MFRs, my behavior of MFR will closely approximate the PFR behavior. समझ में आ रहा है? लॉजिकल एक्सप्लेनेशन. दो रहेगा तो ज़्यादा रहेगा, राइट? दो रहेगा तो सब कुछ इट विल बी लाइक समथिंग लाइक दिस, राइट? इफ आई हैव ओनली 2 रिएक्टर्स, इट विल बी समथिंग लाइक दिस. एक ये रहेगा और फिर दूसरा ये रहेगा. But if I increase the number of reactors, gradually behavior will be closer to the PFR behavior. Concentration profile will be similar to the PFR concentration profile.
वॉल्यूम कम लगता है क्या हमें अगर बहुत सारे CSTR दे तो?
That's what exactly we said, na? Behavior of n number of PFR MFRs closely approximates PFR behavior. That means volume कम होते जाएगा ना, because PFR volume is always less. So instead of having a large MFR, it is better to have 5 smaller MFRs in series.
नहीं सर, मतलब PFR से भी वॉल्यूम कम लगेगा क्या?
PFR से वॉल्यूम कभी कम नहीं होने वाला.
क्या ग्राफ में दिख रहा है?
हाँ,
सर यार ग्राफ में तो दिखता है ना कि वॉल्यूम कम हो रहा है.
कैसे वॉल्यूम कम होगा बताओ? ग्राफ में क्या दिख रहा है? कॉन्सेंट्रेशन दिख रहा है, वॉल्यूम थोड़ी दिख रहा है आपको. हाउ डू गेट वॉल्यूम?
हाँ यस सर.
You plot 1 upon whatever XA versus minus R है ना, वो कर्व अलग है, ये कर्व is only concentration versus length of the reactor. Just showing concentration profile in the MFR versus that in the PFR. It's not showing the volume. ठीक है, समझ में आया? Okay. If there are no questions, let us proceed to the next topic. So now we are looking at reactors of different types in series. अभी हमने देखा था PFRs in series last कल देखा था, PFRs in parallel कल देखा था, अभी हमने MFRs in series we have seen, right? So let us see if there are different types of reactors PFR, MFR in series. How do we handle it? हमने किया ऑलरेडी, वी सॉल्व प्रॉब्लम्स PFR, MFR सीरीज का, वही दिखा रहे हैं हमने. So if you have MFR of volume V1, PFR volume V2, MFR volume V3, and initial concentration is C0, flow rate, molar flow rate is F0, and initial conversion is X0, X1, X2, X3, right? So you can use performance equations. हमने यही किया था. MFR के लिए V1 upon F0 is equal to X1 minus X0 upon minus RA. बस C निकाल दिया यहाँ, तो C यहाँ से निकल जाएगा. Then V2 upon F0 integral D is X1 to X2 dx upon minus R for PFR, and V3 upon F0 is equal to X3 minus X2 upon minus R for third reactor. MFR कुछ नहीं है, परफॉर्मेंस इक्वेशन इंडिविजुअली अप्लाई करने का है, नॉट अ बिग डील. ये हमने ऑलरेडी प्रॉब्लम सॉल्व की है इन सीरीज PFR एंड MFR. ठीक है, एनी क्वेश्चंस ऑन दिस? इसमें कुछ नहीं है, सिंपल यू हैव टू जस्ट अप्लाई द परफॉर्मेंस इक्वेशंस फॉर ईच रिएक्टर सेपरेटली. Okay, so next topic is MFRs in parallel, because we are looking at everything, all combinations. PFRs in parallel देखा, PFRs in series देखा, MFR in series देखा, MFR in parallel. So if you have what you call n reactors in parallel, so you have initial concentration CA0, conversion XA0, so you divide it, flow rate जो रहेगा, suppose यहाँ पर FA0 है, so divided into 3 flow rates, FA0 1, 2, 3 whatever, and it goes to different reactors. So essentially यहाँ पर XA1 रहेगा conversion, यहाँ पर XAI रहेगा, XAN रहेगा. So tau 1 is again, this is a performance equation for MFR. Individually you are applying it for separate all the reactors in parallel. So C0 XA upon minus RA for the first reactor is equal to V1 upon V1 C0 upon FA0 for the first reactor. Similarly for all the reactors. So if you take material balance for any reactor, हमने देखा था राइट, tau I is equal to CA0 XAI upon minus RAI, यही सेम इक्वेशन फॉर ith reactor is equal to V0 VI CA0 upon FA0 I. So what you get is VI is equal to FA0 I into XAI upon minus RAI. So we can find out the volume of any reactor if we know the conversion and the flow rate or molar flow rate and the rate. Okay, just applying the performance equation for a mixed flow reactor to each reactor or in any individual reactor. Okay, so consider reactors of equal size. Generally अनइक्वल साइज नहीं रखते कहीं भी, इंडस्ट्री में जाएंगे नहीं, यू फाइंड सेम, बिकॉज अल्टीमेटली अगर एक रिएक्टर खराब हो गया तो you should be able to replace it. If you have different size reactors, then it's going to be difficult. So most of the time you'll see batch reactors almost same size, 5,000 liters, 10,000 liters, standard size रहता है. Right? You don't have 5,000, 6,000, 7,000 ऐसा नहीं रहता. 5,000, 10,000, 15,000 liters ऐसा रहता है. So there are standard sizes available. So you say we are saying it's equal size reactors. So volume of each for is equal, and we are saying isothermal conditions लिया and equal flow rates लिया. Volume अगर same है तो we have to keep flow rates also, molar flow rates also equal to get the same conversion. Right? So tau 1 equal to tau 2 equal to tau 3. So tau is equal to V CA naught upon FA naught. And ये same equation लिया you can get, ये तो हो गया किया था, right? So V1 upon FA naught is equal to V2 upon FA naught 2 हो जाएगा, ये सब हो जाएगा, right? And that is nothing but XA for the first reactor upon minus RA for the first reactor, XA2 for first reactor upon R minus RA2 for second reactor. Like that you get everything equal because you have equal size reactors, equal flow rates to each reactor. So we can write this as XA1 upon equation लिखा RA का for any order K into C naught raised to power n 1 minus XA1 raised to power of n. Similarly XA2 upon K C naught raised to power n upon 1 minus XA2 raised to power of n. Now if you want equal conversion, because ultimately production कोई चाहिए अपने, right? We want always same production. हो गया, कहाँ से आ गया ये? Okay, so if you want same conversion, because ultimately you want same product from each of the MFRs in parallel, so we have to keep say same for each reactor. That will happen only when the rate is same. So volume of the reactors, all reactors will be, total will be V, which is nothing but N into VI, right? So FA naught is total molar flow rate, FA naught I, which will be, again we have divided by N because we want same conversion. तो flow rate भी same रखना पड़ेगा, volume same है, so we get divided by n depending on number of reactors. So we substitute in this equation, substitute 4, 5 and 3, right? 3 equation में 4 and 5 substitute किया तो what you get is yeah, Vi is nothing but V upon n. Volume of any reactor is nothing but total volume of all mixed flow reactors divided by n. FAI is nothing but you are equally dividing each reactor, so FA naught upon n and XAI upon minus RAI. So we get same thing, V is equal to FA naught XAI upon minus RAI, which is the same thing as what we have for normally mixed flow reactors, right? So for MFRs in parallel, conversion achieved in any of one of the reactors is same as that achieved if all reactants are fed one stream of one large reactor volume V. मतलब क्या? Conversion achieved in any one of the reactors is the same as that achieved if all reactants are fed as one stream to one large reactor of volume V. So it doesn't really matter whether you take one reactor or 10 reactors. Conversion उतना ही आने वाला है. There's no advantage in having MFRs in parallel. तो एज यू हैव सीन एमफार्स इन सीरीज लिया तो एडवांटेज मिलता है। क्या एडवांटेज मिलता है एमफार्स इन सीरीज रखा तो?
कन्वर्जन इंक्रीज होगा।
कन्वर्जन इंक्रीज होगा? नो, अभी देखा था हमने। व्हाट इज द एडवांटेज व्हेन वी कीप एमफार्स इन सीरीज?
लेस वॉल्यूम में
सर
कोई
वॉल्यूम
कन्वर्जन
कम लगेगा।
वॉल्यूम कम लगेगा बिकॉज इट अप्रोचेस प्लग फ्लो बिहेवियर, राइट? नॉट पैरेलल सीरीज। Right? So if you put instead of one MFR, if you put two MFRs in series, the total volume required will be less, right? Compared to one single large MFR. So if I increase it to 3, again it will be less than 2 MFRs in series, and it will be less than 1 MFR. So if I keep on increasing the number of reactors MFRs in series, my total volume of those n reactors MFRs in series is going to be less than a single MFR, right? What does means is right. So if there is suppose a requirement of a large MFR of 1000 liters or 10,000 liters, suppose, right? Then I can break it up into 5 MFRs, and then definitely the total volume of those 5 MFRs will be less than 10,000 liters. So if I increase the number of reactors,
सेम
suppose
कन्वर्जन के लिए ना सर?
same
सेम
conversion. Always same conversion, because you want the same conversion, same product, same flow rate, everything is same. You're just comparing कि मैंने एक में लार्ज MFR लिया 10,000 लीटर्स का, या दो लार्ज MFR लिए, दो MFR लिया, तो टोटल वॉल्यूम कितना होगा दोनों MFR का मिला के? वन इज गोइंग टू बी लेस देन 10,000 liters. If I increase it to 3, it will be less than that required for 2 reactors. If I increase it to 4, it will be less than that required for 3. So that is what it means. जैसे मैं बढ़ाता जाऊंगा number of reactors, my behavior will be approaching that of PFR, because PFR is always the lowest volume.
हेलो सर।
Yeah.
सर लेकिन हम वॉल्यूम को क्यों कंसीडर कर रहे हैं? वैसे भी वॉल्यूम जैसे जैसे रिएक्टर्स बढ़ेगा वैसे वैसे कंस्ट्रक्शन कॉस्ट भी बढ़ेगा ना।
या कंस्ट्रक्शन कॉस्ट बढ़ेगा, लेकिन टोटल वॉल्यूम तो उतना ही रहेगा ना, मटेरियल कॉस्ट उतना ही
उससे
रहेगा ना।
अच्छा है कि एक ही एमएफआर यूज कर लेना, उतने बड़े थोड़े से बड़े वॉल्यूम।
सपोज आई टेक
क्योंकि मटेरियल भी ज्यादा लगेगा ना सर,
Okay.
रिएक्टर बढ़ाएंगे।
Okay, I'll give you an example. मैंने अभी थोड़े दिन पहले देखा था. I'll tell you the example. As n approaches infinity, the total volume required for MFR approaches PFR volume. आपको याद आ रहा प्रॉब्लम्स किया था हमने PFR MFR का वॉल्यूम? What is the ratio of PFR volume to MFR volume for the same conversion? कितने प्रॉब्लम्स किए थे हमने देवेंद्र?
हाँ किए थे।
क्या रेशियो था? रेशियो ऑफ MFR वॉल्यूम टू PFR वॉल्यूम. They solved many problems. I'll give one example. Example 5, problem 5.12 of 11th scale. MFR में volume was 19,960 liters. And the same problem for PFR.
24 लीटर आया था। 24 लीटर आया था PFR।
आया था ना, वही देख रहा था मैं। ट्राइंग टू फाइंड द प्रॉब्लम। प्रॉब्लम नंबर क्या है उसका, याद आ रहा है क्या?
5.12 सर।
5.12 तो MFR है ना, PFR वाला।
हाँ सर, वो दोनों एक साथ है। पहले MFR पर किया था और उसके बाद PFR।
हाँ, but I was looking at the 11th scale का problem है। I was looking at the, because I have answers written on the book. Yeah, 124. Yeah, 124 liters आया था, right? So what is the volume ratio, Devendra?
सर नियरली बहुत है।
That is what is the order of magnitude is. 20,000 to 124 कितना हो गया? कितना हो गया ratio? It's like 100 times almost.
Yes, sir, 160 times.
Right. So it will depend on order of reaction. It will depend on so many factors, but order of magnitude, it's like almost 50 times or 100 times, and that is why PFRs are more widely used in industry than MFRs. But जहाँ पर ज़रूरत है MFR का, ऐसा नहीं कि नहीं करना है, ज़रूरत पड़ती है MFR की. Then what it's saying is, instead of using one large MFR, use 2 MFRs or 3 MFRs or 4 MFR, because then you are going to have total volume which is considerably or significantly less than the total volume required for a single large MFR. Right? And अभी थोड़े दिन पहले देखा था मैंने, suppose I go to a pizza joint, right? And I order pizza. Very interesting example. 12-inch pizza रहता है और दूसरा कौन सा रहता है? Suppose 6-inch pizza लिया मैंने, right? Suppose this is rupees 700 rupees, and this is say rupees 300 ले लो or 350 ले लो, suppose, whatever rate, I don't know. Price is not important. Let's not worry about the price. Now, question is one large pizza equivalent to 2 small pizzas? क्या वो 6 इंच का है, 12 इंच का, राइट? तो मैं बोलूँगा ठीक है, मैं एक लार्ज के में दो स्मॉल मंगा लेता हूँ. इज इट द सेम? क्या देवेंद्र?
कि वो पंप कॉस्ट और सब आएगा ना एजिटेटर
हाँ?
का, और
क्या
पंपिंग कॉस्ट सब वो आएगा ना सर एजिटेटर का?
वो छोड़ो. See, ultimately what we are looking at is, see, when we put up a plant, you want to minimize the plant cost, right? Plant cost is, suppose instead of 20,000 liters, I need a reactor of 100 liters. What would I go for? पंपिंग कॉस्ट मिनिमाइज करने के लिए 20,000 लीटर्स लूंगा कि 120 लीटर्स का ले लूंगा रिएक्टर? कितना होगा पंपिंग कॉस्ट?
120.
Pumping cost is not going to be
Yes,
significant. The reactor cost is significant. Plant cost is significant. And now, if you compare this, I'll leave this as an example or homework for you. Find out if these are equivalent. You tell me tomorrow. ठीक है?
हाँ सर.
ये आपके लिए होमवर्क है, just for you to have a thinking or thought process कि are 2 small pizzas equivalent to 1 large pizza? Forget about the cost. ठीक है. अच्छा, शिवानी had suggested कि संडे को टेस्ट रखना. Is it okay with all?
सैटरडे बोली थी
हाँ
सर, वो सैटरडे बोली थी हमको, आपको
मेरे को संडे बोला क्योंकि सैटरडे को आपका प्रैक्टिकल रहता है ना. नहीं, यू डिसाइड, मेरे को कुछ प्रॉब्लम नहीं है. दैट्स व्हाई आई थॉट आई ब्रिंग इट अप. यू डिसाइड, लेट शिवानी नो. एंड शी वाज सजेस्टिंग कि एमसीक्यू नहीं न्यूमेरिकल रखो. इज दैट ओके विथ यू ऑल? क्योंकि एमसीक्यू में पढ़ाई नहीं
Yes.
करता. क्योंकि एमसीक्यू में पढ़ाई नहीं करता बोलते. ठीक है, सो कंफर्म कर दो मेरे को, प्रॉब्लम नहीं है, कल तक कंफर्म कर सकते हो. ओके ठीक है, विल स्टॉप हियर. एंड इफ यू हैव